Hello everyone and welcome to yet another live stream, and today we will be playing Grand Theft Auto 5. Oh my goodness, I am... Okay, give it a second. There we go. So, first of all, what happened? Why do I only have $428 on me? That's not a lot. What happened?
If a repeat customer is any indicator, you might not be bad at this whole, thing. After all, that person I put you in touch with, he's got another job. If it's anything like the last job, I won't want to know anything about it except for the finder's fee. Don't worry.
Alright, so I guess the goal for today would be to make some money, because we have only 400... We have only $428. How did this happen? I didn't buy anything, did I? What did I buy? How 420? That's okay. In GTA, $400 is nothing. I am well. All right, let's make some money then. My mechanic takes $20 a day. I'm certain it was them. Yeah. I am certain. All right. By the way, don't mind the name of my guild. It's just I needed a name that would put fear into the souls of my enemies, and just, you know, just seemed pretty reasonable. All right. Okay, we do have only $400, which means we should make some more money, which means we shouldn't really pass any business opportunities. So, you know what, let's take every business opportunity we can. So, reader said, I just have to pay a visit to a good old friend. Alright. Yeah. I will buy. I'll just try to buy as much as I can. $400, great. Well, yeah, could I have some money, please? No witnesses. Or maybe some witnesses, right? Maybe 2 witnesses, I'll allow that.
I hope you sleep well tonight.
I mean, it's hard to sleep not well when you have 2K in your pocket, right? I mean, I'm just saying. I know it's morally, you know, probably not right, but at the same time, I am a streamer, so morality is not really my thing. Oh boy, that's a great source material. Now let's go make an honest day living with my honest money printing facility. Actually, wait, my facility is forward. Why am I turning? Oh, that's probably why. My Misa. There we go. That's an all-terrain vehicle. Kind of, almost. I mean, you lost the police, that's good. It was all part of the plan. Just another day, making an honest living, selling money. There we go. I told you this would be faster, kind of. Why would I go that way when I'm going this way? I mean, logical next step. I will not be defeated by some piece of dirt. Quite literal. Alright. Yeah, I know. Say I've run out of jokes. I'm just, you know, comical situation, right? I'm using a military grade vehicle to just skip a kilometer. That's comical, right? I don't know. Don't mind me, sir. Just driving by. Oh, we could do a heist. That's a great idea. But first, let's do the money thing. And there we go. Not a single scratch. Well, don't mind the scratches. Hi there. Also going to walk, right? Yeah. Oh boy, what a coincidence! We have our very legal money printing station in the exact same place. Yeah, supplies are running a bit low. Don't mind the user, it's just don't mind that. Anyway, I've never maxed out on stock, so that would be the first. Oh, it's the Vance mission. It's one of... Well, it's not the most annoying one. It's certainly doable. I should switch a car, probably, because this one is not well equipped to being in the city. Yeah, let's switch. I'll need to call a mechanic, but they won't answer, because I am in my own personal vehicle right now. So, we just need some temporary solution. I know if you... Yeah, well, I mean... You started the thing. Oh, $17! That's neat. So convenient. Just when I needed money. Yeah, this is not much of an improvement. Well, don't mind that. It's not much of an improvement, but soon we'll be crossing a road which has the best cars in the entire GTA. Best cars that can just spawn randomly, obviously. I could call for Turismo, but I don't know. Actually, let's do it. Probably would be better.
I'm on the clock. What you want? Some wheels?
Yep. That's the blue one, right? A good tip is to always look back with fudge, didn't work. Usually your personal vehicles don't spawn your side, so when you look backwards you are driving towards your personal vehicle, but I guess this also works. I have no idea why, but for some reason the pink Turismo is indestructible. I have no idea why. If you want to, you can go watch the previous live streams and you will see that the black one got destroyed, the blue one got destroyed multiple times, but the pink one survived every single time. I have no idea why. It's just magic. Of this GTA chase music. It's just one 2-second long melody on repeat. Except for the last 30 seconds. Last 30 seconds are intense. Don't mind me, sir, just driving through. How is it? How is the pink Turismo still alive? This is how it looks normally. My driving abilities, I mean, obviously. It gets wrecked left and right. Always survives. Yeah, perfect. Yep, exactly what we needed. I am good at this. Alright. No time to slow down. No, drive carefully. It is time to... Hi there, hi there. How's the day going? I'm sorry for not saying thank you, by the way, but the second I watched the video sent, I just had to make a video of my own, and well, yeah, it's amazing, both of them. All right, let's just. Actually, give me a second. There's one thing I just realized. Okay, fix the thing, fix the problem. Yeah, I mean, it's great. When I when I clicked on the channel and went over to Open Muscle, that's so impressive. I mean, I don't know what to say. Open Muscle is just so amazing. It's just, I'm speechless. I am speechless. I tried to convey it in the video, but it's just an insane project. Well, just calling it a project even seems inappropriate. It's bigger than that. Alright. I still work with machine learning because I honestly thought it would fail. I mean, it didn't, and I would say it worked out pretty well. Also, the concept is really great in my opinion. Using machine learning, machine learning is obviously great, but people really often misuse it for, well, weird things. So it's really nice to see someone use machine learning for a good reason. It's very refreshing. You don't find people like this often. Random forest regresses. Sorry, I don't know what it is. I am not. I mean, I'm very much a newbie when it comes to machine learning. I mean, I know only basic things. I mean, the best thing I've ever made with machine learning is I made my own LSTM based machine learning program in C, and that's the biggest project I've ever made. So I am very much a newbie, unfortunately. I couldn't it requires too much abstraction for me. I am not good with high abstraction things, unfortunately. Yesterday's streams while trying to. Yeah, it's one of the projects of mine. I don't really think it's going to work out that well. It's called hyper operational mathematics. So basically, it's mathematics except it's based. I'm sorry. Oops. Well, it's mathematics except it's based on hyper operations. So starting with addition, multiplication, exponentiation, tetration, and then higher orders. Except I'm trying to generalize it for every single operation. It could, I mean, I do believe it could be useful because there are many functions which cannot be described using our current tools. Very famous is one really famous example is obviously the integral of normal distribution, if I'm not mistaken. I do believe that's one thing that cannot be described using our normal functions. There's a name for this, I right now forgot. Yeah, and basically, I think that hyperoperations could be one of the solutions for them, because, well, there's quite literally an infinite amount of them, all of them very different. The problem is only that it would require generalizing over every single hyperoperation is difficult, especially when they change so much. I mean, one example would be commutativity, right? A plus B is equal to B plus A times B is equal to B times A, and then, yeah, it is cool, but I don't think I have the mental capacity to finish that, honestly. It really is not an easy thing to do. I do have an other side project called Space, Life and Time, for which I will live stream tomorrow. For now, I just want to balance the gaming part of the live stream and the research part, because some people find the research, well, let's say, not a good live stream material, but it is a decently cool project, except I really don't think I have the capabilities for that. It's, yeah. Because there's almost nothing you can go off, that's the biggest issue. And also, exponentiation is kind of the only operation that is really useful, because when it comes to addition and multiplication, as I said, A times B is equal to B times A, which means that really often the results, when you are trying to predict what higher order operations, how they would work, your results really often get skewed because of the fact that you don't know which way should you apply the operation. I did try to combat this for a while by saying that, but by defining multiplication also not commutative, because it is not for quaternions. The only issue being that it's a very temporary solution and it wouldn't work. I'm kind of lost, because there are three kinds of, it's a whole thing. it's a lot of very boring terms, which are technically useful, but very much technically useful, not really useful. There were a couple of cool endpoints. For example, if someone one day would finish hyperoperational mathematics, then there's a possibility that we could have a pseudo-useful, yeah. If someone were to finish hyperoperational mathematics one day, then we could have a finite... There's a possibility that we could have a finite equation for pi, for example. Like, a finite equation, which I could write down right now, except I don't know any variables for that. Nor how many variables there are. But there is a possibility that you could write down an equation for any number without using infinite sums or integrals or anything like that. So without screwing with infinity or zeros, instead of 1 divided by n, yeah. You could write a genuine finite equation for any number in existence. The only problem is, well, the biggest problem is that there isn't really there aren't any really good analogies for hyperoperations. For exponentiation, this already becomes a problem. I mean, when you have a to the first power, that's just equal to... You could define that as a line with a length of a. When you have a squared, you could define this as a square with side equal to a. When you have a cubed, you could define it by a cube with a side, and so on. Then to the 4th dimension, 5th dimension, 6th dimension. But tetration is not even about the dimensions at this point. I mean, all the dimension references, all the dimension... What am I trying to say? I am not good at multitasking. Basically, every single dimension interpretation is all about exponents. So, well, dimension n would be just x to the nth power. So tetration by itself already is beyond dimensions. And then tetration is not even the last thing, it's only the 4th hyperoperation. Then there's the 5th one, the 6th one, the 7th. If I could find an interpretation for why they would be useful, then I would resume the project. But the problem is, there is a reason why we don't use tetration in everyday mathematics, and it's just not really useful. Ah, you got me excited. Give me a second. Now I have to Google. Real uses of titration. Live uses of titration. Visualization for something like this. Someone with PhD in mathematics says, as mentioned earlier, there aren't really any applications where you need titration. Dang it! I think it is fairly well worth learning about, especially since it is so simple to understand. It is not, though. No, the basic concept is, obviously, but unfortunately, the rules are just that. There are not enough rules, I would say. Should I change the theme of the stream? Could be an idea. Because talking about this actually without explaining could get messy.
You're through to your garage. You, need me to bring you around?
GTA titration, yeah.
It's coming at you.
That's the best way to play GTA, just explain titrations. No, well, not exactly titration. Just all of them hyper operations. The one thing that really upsets me is the fact that the only the operation that doesn't fit, the only operation that doesn't actually fit the description is addition, which is the base. So alright, let's go forward. Oops. Want to learn about this actually. Well, I mean, I could resume that. You're making me regret about my decision. Well, the theme of the stream for today. I could switch. That's a good idea. I should switch. I might switch. There is a possibility. Yeah, but no. The benefit of being a small YouTuber is that it's a benefit. Well, some people wouldn't call it a benefit, but yeah, but you really made me want to change the theme of the live stream. You know, now I'm. Okay, that's it. Science and technology. Ever so quickly change the thumbnail to add the thing. I am very easily convincible. Alright. Change the outline to blue because this is... And for the first time in 50, 70 days, we have two thumbnails for the... Why am I saying it so weird? There we go. So hello everyone and welcome to yet another live stream about hyper operations. I am easily influenced. There we go. Docs, google.com and hyper operational mathematics. Now screen main and there we go. So, great. Alright, what was the thing that I was trying to solve yesterday, right before I gave up? Hyper operations, obviously. So first I should probably explain the issue. Maybe not the issue, only the bit that makes it so inconvenient. Basically, we have three types of operations here. The hyper, anti, and hypo. Technically, there are also anti-hypo, but that's the same relation as between these two. Hence the notation like this. So, basically, So anti-hypo aren't that important because these are just these reflected. So basically, when we have these three, right? The biggest issue with them all is the fact that this one and this one are most of the time indistinguishable. So for example, we have A plus B is equal to C. That's a hyper operation. A times B is equal to C, and A to the power of B is equal to C. Then we have, then over here, in order to complete this equation with anti-operations, we have C minus B is equal to A. Right? Is that right? I mean, I know that it is right, but would this be right for an example? Because C divided by B is equal to A, and then C root B is equal to A. Yes, there we go. And then this one, that's a very weird one, because over here, the hyper operation will be just the logarithm. So logarithm of A, right, AC is equal to B. But for subtraction and multiplication, we don't have that, because there is no need for it. We can calculate B using subtraction, like this. And over here, it's C divided by A, that's equal to B. So that's the issue. This only exists when A operated, some operator, I don't know, operated on B is not equal to B operated on A. I know I used the quantum physics position operated, doesn't matter. That's the only case when this is not equal to the anti-operation. And that's what makes it so upsetting, because it's a very slim margin. Tetration is a mystery, pretty much. There's almost nothing about tetration in comparison to the other operations. And addition and multiplication are useless in this sense, because they tell us almost nothing. Which means the only thing that we can use to draw conclusions is exponentiation, which is surprisingly not useful, because there is only basically one example of what's going on. And that's the main issue with that. When trying to figure out how hyper operations work, then we basically have to just go with the exponentiation and guess for tetration. Tetration is only defined for integers too, and it's going up extremely quickly. So it's very upsetting. All right. There are a few, well, there is one thing that makes it a bit easier. Those are the twos. The twos case is very interesting. I really like that. When it comes to the twos, then we can say, insert equation, please. There we go. We can say that 2 up arrow n to any hyper operation is always equal to 4. Is there paper, or how does this come up? Is that what is difficult? Well, yeah, the problem is that no one really cares about that. And for a good reason, for a very good reason. Hyper operations are not something that's very used in mathematics, because why would you use them? The tetration, you never use tetration. The tetration gets really high really quickly. I mean, don't mind the errors in Python, it's just something that happens. That's massive, and that's just 3 tetrated 3. 2 tetrated 2, it's still relatively small, but 2 tetrated 3. Well, if I don't. 2 tetrated 4, and now it just jumps. Or maybe it was 5. Oh yeah, 5 is massive. So yeah, we have 4, 16, 65,000, and just absolutely ridiculous. So that's why titration isn't really used that often, but it could be useful, where the famous diagram taking the infinities and bring them to a tangible number. Oh, whoa. If it is to bring a tangible number, please tell me there is easy way to find this here. Visual representation of physical reality. How did I not know about that? I'm... I'll just take a sip of water. Alright, let me just type this second and Feynman diagram summation. Alright. Oops, not what I meant. For beginners, that sounds great. Bring them to a tangible number. That actually sounds like it could be extremely. There's one case where that would be extremely useful. For the negative function of, for the second negative function, that is exactly what I need. Give me a description of it. Yeah. Sorry, time to learn about quantum physics. That'll be. I don't need that for later. Where's summation methods of computation? Thank you. Specification multi sums. Oh, this will require quite some research. Yeah. I mean, this is definitely, well, it won't do any harm, so you know. But there's some tangible way to see the data. Yeah, that's what I said. It will require further research. So there are a lot of layers to this. I mean, this is the relevant page is page 110. So Simplification of multi-sum expression. That's indefinite nested sums in the products. That okay. This will not be an easy read. Okay. Oh, am I mentally prepared for this? Not yet. I'll not yet. I need a second. Okay. So it's tempting. There's a lot of references though. Alright. Keep it on hold for a second and well, we just need to ban everyone else. I mean, most people who join are already terrified by most of the notation in math. Okay, because here's the thing: the reason why this could be useful. Well, there are actually many reasons why this could be useful. The negative function, this. I can unwrap the negative function. Because yeah, that's one of the candidates, but that is a very weak candidate based only on 3 examples. That basically goes off the fact that a minus b is equal to a plus b times -1. A divided by b goes off the fact that a times b to the -1st, and then based on that theory, a rooted to the b would be equal to a to the power of b to the -1st tetrated. The only problem is that tetrate, if I'm not mistaken, for -1, I don't actually remember right now. Was it undefined or was it equal to 0? Yeah, that's where the relation comes from, by the way. That's the upsetting part. It's only when n is greater than 0. I'll do wait. Based on that, 3 to the 3 tetrated third would be equal to 3 to the 3rd power. Wait, no, 3, yes, so this would be equal to 3, well, I should use different numbers. 3/4, I do have to use integers, cannot use any blank numbers, because when recursion is relevant, adding the ... really messes up the entire thing. So 3 to the 3rd power tetrated to n-1, so to the 3rd, yes, and then that would be equal to 3. I know making step by step seems like a very slow way to do it and pointless, but 3 to the 3rd power to the 2nd, there's a reason behind the madness in this case. 3 to the 3rd, also I should be doing it in LaTeX because this will be unreadable, to the 3rd, and to the 3rd to the 1st. Yes, there we go. Grand. Now 3 to the 3rd will be just this, so what will be equal to 3 to the 3rd to the 3rd. I don't know if I need to add those brackets actually. 3 to the 2nd will be equal to 3 to the 3rd. 3 to the 1st would be equal to just 3. 3 to the 0th will be equal to 1. And by the same logic, every single time what we are doing is we are taking operation of x which removes these actually down. Yeah, because taking this one from the inside will be, well, let's just say upsetting because it's going from the up down. No, from the down up. So yeah, taking this one. So let's just say it brings this entire thing down. And there is one equation which does that, which could be really convenient. So when we have this, let's say x is equal to 3 to the 4, 3 to the rated 4th, right? Then if we take the natural log of x, we could describe that as 3 to the third natural log of 3. Am I wrong? I think this is correct. Because then, if we take the natural log of x tetrated to the n, what we get is x to the n minus 1 natural log of x. Wait, that... Wait, this actually could be useful. What if we can generalize that? What if this is not just some random except what if this is the rule between them? The very interesting thing is that we will have to work with hyper operations on... Okay, let's see if this is the rule. Let's see if this is the rule. I should take some... Yeah, let's just do problems. Let's just call it the, I don't know, hyper operational properties. Yeah, it's not neat, but right now I should focus more on the doing stuff than just writing in a nice way. So, first, let's create a bit of a cheat sheet. What I meant to copy. Let's just do this fixed points. Yep, good enough. First, let's just do a bit of a cheat sheet for us so that we will know things like up arrow this, A, up arrow B is equal to C. Let's work with this, A, B, and C, so that we would know the order in which they go, because this will be very upsetting once the hyper operations go in. So, nope, that's down arrow. There we go. And based on that at the top, a to the b's power, this is obviously addition in this case, but let's say a to the b's power is equal to c, which means c rooted b is equal to a. Because we take root of b on both sides, yes. Now when it comes to hyper operations, this would be base a, up arrow, so logarithm base a to c is equal to b. There we go. And now we just have to check if it works for 4 cases. So first of all, let's get the assumption. Assumption is generalized form, obviously, because that would be more convenient. And assumption is on my paint. So in brackets, x up arrow and up arrow n, like this. Well, I'm using n here, that's bad. B. So A operated up B, down arrow, no, up arrow, it's already getting confusing, that's the issue. So log, natural log, well, let's just say that will be log C, because why not? And the theory is that this will be, oh, this is so very upsetting. Also, it's multiplied. We have to generalize that. This is the theory is that the right side will be will look like this. Oh, that's the base. Oh, I made. See, like this. And now up arrow n minus 1. No, this is the iteration. So this will be genuine multiplication. I don't really like that definition, but fine. And then this will be x up arrow. Yeah, I think you can already tell why these equations are not that convenient to write. And down arrow 1. This is the theory. So yeah, basically this is what we are trying to prove, that this is the case. First of all, log properties. Because if I get the properties alone of the logarithm wrong, then that's also, I mean, it is also, if this will be true, then that's was not okay. It wouldn't be massive, wouldn't be huge, but it will be big, because this would be a description of hyper operations, which could actually be useful. Hopefully. So, because then what we could do is we could do this. Well, we couldn't do that forever, but we could eliminate the hyper operation. And if we eliminate the hyper operation, for example, by bringing e to the power, right, then we would have e to the power of natural log, so like this, and this would be equal to e to the power of x n minus 1 natural log of x. And the convenient thing is that we can keep unwrapping that, I think, like then this part over here, because this and this has the same form, which means then we could unwrap that, which would look something like this. E to the x n minus 2 natural log of x natural log of x. Like this. Yeah, we could keep unwrapping that, so this would be relatively useful. Now the only question is, does it hold? And we should check for all 4 cases, which means addition, multiplication, exponentiation, tetrration. For all 4 cases for which we can check. Pentation would be suboptimal, considering that we cannot recheck. Now, first, let's try with first, which means just first. There we go, first case. Yeah, I'll make this pretty later. For now, it's time for the hard math. So, we just replaced n with 1, or in other words, we just do this. To keep only one arrow everywhere, because that's our n. And this shouldn't be an n. Oh, I already messed up. This shouldn't be an n. This should be a b. Should it be a b? A to the b's power. A tetrated to the b, which means this should be a b, yes. And this should look like this. Great. Now, okay. Okay. So now what we can do? I just realized we would be missing hyperoperational properties. Yes, we would be missing them. I should check some first. For example, if you have AC, so let's add some more helper equations here. This is basically to which power you have to, yes, which means if we take this, and if we do A up arrow like this, what we get is C. Makes sense, obviously. It's obvious, but I better save than screw up an equation which will be this long, this many different characters. Great. Can we do something with that? Not really. Fudge. Alright, let's untangle it step by step. The basic idea here, also what is this x doing here? The x is equal to a, n is equal to b. Great. Basic idea is to untangle this equation so that in the end we would get these three equalities, hopefully. Hopefully we'll get them. No, wait, we will not. We should check with... Okay, so we do have to check with an actual example. So let's just set a equal to integers, obviously, because it would be terrifying. A equal to 5. Let's use prime numbers so that it will be messy. I'm using ChatGPT 4 to inform me on what you are doing. Okay. Let's use actual, as I said, integers to double check ourselves. This is C, so 11. A, which is 5, 7, 5, 7, 11. And A is just equal to 5. Great, step by step. This should be an equality. And I really hope it will be. First of all, 6 minus 1, that's... 7 minus 1, that's 6. Then 5 plus 6, that's 11. Yeah, I do think I should give up on generalizing this hard and I should just go for these easier examples just to check if what I'm saying could be true. I should also probably add this, which is 7 plus 5, 12. If I make a mistake in simple addition, oh boy, will this be fun. Now we have 11 over here, and 11 hypo-operated 5. Hypo-operation, as I said, in relation to addition, doesn't really exist in normal math, but we can kind of make it exist. Because of these three equalities. So over here, what we have is we have the A and we have the C, which means we can bring them into an equation like this, which means A and C. Now we know that A is equal to 11, C is equal to 5. I know this is not correct, but just in this case, which means we just have to find B. B would be the number. 11 plus B would be equal to 5. So what number do we have to add to 11 to get 5? Negative 6, if I'm not mistaken. So we just subtract 6 on both sides. It's yes. So negative 6. 11 plus negative 6, that's 5. If I'm wrong about this, that would be very upsetting. Please don't be, please let me not be wrong. So negative 6, that's the number we are looking here for. Which means, right now what we have to do, also left side, I should probably solve the left side. Which is the exact same scenario. We are looking, let's do this with subtraction. Because I feel like, or maybe the sum of addition because that's big. Okay, great. So this is A, this is C. So A is 11, C is 12, which means B is equal to 1, which means this is a 1. This is not equal. This is very much not an equality. I I don't think that's an equality. So it's great. That means it cannot be generalized on addition. Oh, I'm pretty certain negative 66 is not equal to a 1. So we already know it doesn't work on addition. I have, okay. Here's the thing, addition and multiplication are genuinely different from other hyperoperations, and up to this day, I still do not know if I should treat them differently, or if I should just generalize over them too. Because there are a couple of definitions we can generalize over the rest of hyperoperations. So for example, we could try this for, well, exponentiation and titration. So let's try it. Let's try it for exponentiation and titration. If it will work for exponentiation and titration, then I'll try pentation, and if it will work for pentation, then what that probably means is that I should exclude addition and multiplication from the basic idea. So, first of all, exponentiation. Over here, everywhere, 3 arrows. There we go. There are no anti-operations, which is interesting. Now C is equal to 11, A is equal to 5, B is equal to 7, so 5, 7, 11, 5. This is by the way correct, I did it correctly, right? X to the N, which means A to the, don't read the Unreal Engine right now, A to the B, X to the N, yes, so N is the B, yep, X is the A, great. Wonderful. Wonderful. Now only solve this. This will be an annoying one. We'll have quite a few irrational numbers. But that doesn't matter, because we can still work with those numbers in an easy way. So, first of all, obvious things, this is a 6. Then we will need 5 to the 6th power. Python, help me out here. 5 to the 6th. There we go. God bless Python. This will be multiplied by the thing on the right, which is logarithm base 11, 5. Great. Can't wait. This will be so much fun. I can 5 to the 7th power, like this. I suppose we can't really rule now if if this will be an equality. Now we have to take log 11 to 78,125, and on the right side we will have log 11 5. Okay, Desmos, help me. Okay, I'm using Desmos as a normal calculator really often because it has a really similar formatting to LaTeX, and it's just convenient. Logarithm 11 78,125, so it's around 4. Okay, good to know, great, glad, amazing. Now logarithm 11 to 5. For some reason I don't think it will be equal. For some reason I just feel like it won't be really equal. I don't think if we multiply this by 15,625 we'll get. Wait, what? Oh, because this is the entire. Wait, what? Wait. 15,625. it is correct, but only if we multiply the inside of the logarithm. Then it's equal. Which means this is not equal. But on the other hand, this is equal. Which means this is not equal. This is not equal. But this is equal. Which means this is not equal. But at least for exponents, this is a very important thing to keep in mind. Very, very important thing to keep in mind. For exponents, this is equal. And I do believe if we write it down using normal mathematical notation, it will be obvious. I just feel like logarithm of c a to the power b will be equal to logarithm c of a to power b minus 1 times a. Well, yeah, as I said, it is obvious. If we use normal mathematical notation, it is obvious. Great. Yeah, okay. Yeah, so it's obvious. Great, that's great. That's all right. All right. So, but changing this equation for tetrahedration won't work, right? Because hyperlog. Oh yeah, we would need hyperlogs for this. We would need hyperlogs. To compute that. To even just... Wait, I made a mistake. This is log. This is not a hyperlog. Obviously I made a mistake. I made a mistake. This shouldn't be... This should be n minus 1. I did make a mistake. Which means this should be 2 arrows instead of 3. Which means if we... I mean, I still don't think it will be equal. No, my hopes aren't high. But this is this case, right? This 11 and 5, so A and B, so 11 and 5, which means 11 fifths, right? Yeah, okay, great. Oops, no, I meant 5 where's this was, there we go. So I don't mean to multiply this on the (11 fifths), which is still. But over here there also should be one less arrow. Yeah, that's why I'm terrified of making mistakes like these. Because this is once again incorrect. This is A and B. A and B, which is 78,125, which means we multiply by B, divide by this, and get 11, which is so very... Okay, it's also wrong. It's also so very much wrong. Yeah, I mean... Huh. Trying to invent math without any interpretations of what you're doing is not easy. Because I can't even check if that makes sense. What could be the interpretation of hyperoperations? Starting with exponents. So we have exponents, tetration, pentation. What's the relation between them? I already know that there's no reason for calculus to work. Already checked. What's the relation between them? Well, obviously one is the higher or the hyper operation. But what does it mean exactly? It means as x increases, so do the dimensions. Yeah, I think I should genuinely give up this project until I find an interpretation for what I'm doing. Because without interpretation, it's just walking in the dark. Trying every single thing until it works, which will take a long time because there are a lot of numbers. There are a lot of numbers out there. At least 5, maybe even 6. So yeah. Wait, if we have a hyper operation... Okay, I should stop trying, I know. I should stop trying till I find an interpretation, but when you have a hyper operation, right? Like... this one. Just delete this. Let's go down to the node part. These are the equalities, right? A to the power b is equal to c, then base a, c is equal to b, this way. That means in order to calculate b, what do we need? Nah, I don't know. No. This time is really the end. I should stop trying. I should stop trying with hyper operations until I find the interpretation for them. If I find an interpretation, that would be great. That would be great because then I could actually do some math where I could, based on some more real things, prove something in math, which would be great. I mean, then I could even prove the omega delta problem, and we could have a finite equation for pi. But until then, I kind of have to give it up. So, I guess that'll be it for this live stream. I'm off to... Yeah, it was a good try. I'm not gonna lie, it was a good try, but I don't think any mathematical tools will help me until I find the interpretation. Because as I said, without the interpretation, it's the walk in the dark. Well, it was a good try. Thank you, Tefta, for being here on the stream, changing the stream. That's the thing you don't get to see every day on the charity checkup. Anyway, Yeah, so that will be it. I really have to go. Here's the video. Plural. So, that'll be it for the charity checkup day number 93. Can't really believe it has been 3 months, but it has been 3 months, and in a week I'll donate $100 to charity because it will be the day 100. So, for now, be it. Thank you everyone so much for watching, and have a great day. Bye.